Top 20 Programming Challenges Interview Questions and Answers. Programming challenge interviews test a candidate's logic, creativity, and coding efficiency. Below are the top 20 programming challenge interview questions and detailed answers to help you prepare effectively. 1. What is a programming challenge? A programming challenge is a problem designed to test a developer's coding ability, logical reasoning, and problem-solving skills. It requires writing efficient, error-free code under time constraints. These challenges may involve algorithms, data structures, debugging, or optimization tasks. The goal is to assess your ability to think critically, code efficiently, and handle real-world programming situations. Strong analytical thinking and structured approaches to solving problems are key to performing well in such technical assessments. 2. How do you approach a new coding problem? When facing a new problem, first carefully read and understand the question. Identify inputs, outputs, and constraints. Then, outline a step-by-step logical plan before coding. Consider multiple approaches and choose the most efficient one in terms of time and space complexity. Test with simple cases first, then edge cases. Finally, optimize and refactor your solution if needed. Clear understanding and structured planning reduce bugs and make your solution more scalable and maintainable during evaluations. 3. What is the importance of time complexity? Time complexity measures how fast an algorithm executes relative to the input size. It helps developers evaluate efficiency before running the code. Lower time complexity means faster performance for larger datasets. Common notations like O1, ON, and O in superscript 2 describe algorithm growth rates. During programming challenges, understanding time complexity ensures you write optimized solutions that handle large inputs without performance issues. Mastering this concept is crucial for creating scalable, production-ready systems in real-world development. 4. Explain the concept of space complexity. Space complexity determines how much memory an algorithm consumes relative to input size. It includes temporary variables, data structures, and recursion stack space. Efficient programming requires balancing speed and memory usage. For example, algorithms with O1 space complexity are ideal because they use constant memory. In coding challenges, analyzing space helps avoid crashes and inefficiencies. Understanding both time and space complexity allows developers to create robust, high-performance solutions suitable for large-scale data operations. 5. How do you optimize your code during a challenge? Optimization begins by identifying redundant operations and unnecessary computations. Use efficient algorithms, data structures, and built-in library functions. Avoid nested loops when possible, and replace them with hash maps or sets. Minimize space usage and handle edge cases early. Use profiling tools or print statements for performance checks. Always balance readability with efficiency. Clean, modular code is easier to debug and improve. Optimization is an iterative process that often turns good code into exceptional code. 6. What are common data structures used in challenges? Common data structures include arrays, linked lists, stacks, queues, hash maps, trees, and graphs. Each serves a unique purpose. Arrays for indexed access, stacks for LIFO operations, and queues for FIFO tasks. Hash maps optimize lookups, while trees and graphs handle hierarchical or network data. Selecting the right data structure improves both performance and clarity. 7. What are the most common algorithms in coding interviews? Common algorithms include sorting, quicksort, merge sort, searching, binary search, recursion, dynamic programming, graph traversal, DFS, BFS, and greedy algorithms. These algorithms help solve problems related to optimization, pathfinding, or computation. Employers use them to evaluate logical thinking and algorithmic understanding. Knowing when to apply each algorithm efficiently demonstrates mastery. 8. How you handle edge cases. Edge cases test how your program performs under extreme or unexpected conditions, such as empty inputs or maximum limits. To handle them, analyze constraints and plan for unusual scenarios early. Test thoroughly with varied inputs. For example, if input is null or 0, your program should respond gracefully without crashing. Handling edge cases demonstrate attention to detail, resilience, and foresight. Key traits interviewers look for in strong, reliable software developers during programming challenges. 9. What is dynamic programming? Dynamic programming, DP, is a technique for solving complex problems by breaking them into overlapping subproblems and storing results to avoid recomputation. It optimizes recursive solutions using memoization or tabulation. DP is ideal for challenges involving optimization, such as the knapsack problem or Fibonacci sequence. By reusing prior results, DP reduces time complexity significantly. Mastering dynamic programming enhances your ability to create efficient, scalable algorithms that handle intricate computational problems effectively in interviews. 10. Explain the difference between recursion and iteration. Recursion involves a function calling itself to solve smaller instances of a problem, while iteration uses loops to repeat actions. Recursion is elegant and simplifies complex problems like tree traversal, but it consumes more memory due to function call stacks. Iteration is faster and uses less memory, but can be less intuitive. Choosing between them depends on the problem's structure and efficiency requirements. Understanding both approaches shows strong conceptual depth in programming challenges. 11. What are hash maps and how are they used? Hash maps store data in key value pairs, allowing for constant time retrieval on average. They're commonly used in challenges requiring quick lookups, counting frequencies, or avoiding duplicates. Hashing converts keys into indices for efficient data access. However, handling collisions through techniques like chaining or open addressing is crucial. Hash maps improve code speed and readability, making them a powerful data structure for many real-world and interview-related problem-solving tasks. 12. What is the role of testing in programming challenges? Testing ensures your solution works correctly and handles all input variations. It helps detect logical errors, inefficiencies, and overlooked edge cases. Unit testing validates individual functions, while integration testing checks overall program flow. In programming challenges, writing quick, targeted test cases helps verify correctness under time pressure. Testing also builds confidence in your code's reliability and demonstrates professionalism, qualities every interviewer values in a skilled developer. 13. How do you debug code efficiently? Efficient debugging involves identifying the source of errors systematically. Begin by reproducing the issue, then isolate the problem area using print statements or debugging tools. Analyze variable values, loop conditions, and function calls carefully. Avoid guessing. Instead, test hypotheses step by step. Reading error messages and stack traces also provides valuable insights. Consistent debugging practice helps improve analytical thinking, enabling developers to quickly find and fix bugs during time programming challenges. 14. What are greedy algorithms? Greedy algorithms solve optimization problems by making the locally optimal choice at each step, hoping it leads to a global optimum. They're simple, fast, and work well for tasks like coin change, activity selection, or Huffman encoding. However, they don't always produce the best solution for all problems. Understanding their limitations and use cases helps developers decide when greedy strategies are appropriate. They showcase problem-solving intuition and practical thinking during programming interviews. 15. What is the difference between stack and queue? A stack follows a last-in, first-out LIFO principle, while a queue follows first-in, first-out FIFO. Stacks are ideal for undue operations, recursion tracking, or expression evaluation. Queues suit scheduling, buffering, and breadth-first search tasks. Understanding these structures helps developers design algorithms efficiently. Choosing between them depends on order requirements in the problem. Both are foundational data structures essential for strong programming challenge performance. 16. How do you manage time during coding interviews? Effective time management involves dividing your time between understanding the problem, planning, coding, and testing. Spend the first few minutes analyzing constraints, then outline your logic before writing code. If stuck, communicate your thought process to show structured reasoning. Always test with multiple cases before submission. Prioritizing clarity and correctness over unnecessary optimization ensures steady progress and reduces last-minute pressure. Practice improves your timing and confidence significantly. 17. What is BIGO notation and why is it important? Big O notation expresses an algorithm's efficiency by describing how runtime or space requirements grow with input size. It helps compare solutions objectively, guiding developers toward optimal approaches. For instance, ON indicates linear growth, while O and superscript 2 shows quadratic growth. In challenges, Big O helps avoid inefficient algorithms that may fail large test cases. Mastering Big O ensures you write scalable, high-performance code for real-world and interview scenarios. 18. How do you stay calm during difficult challenges? Staying calm begins with mindset. Take deep breaths, reread the problem, and focus on one step at a time. Break the task into smaller parts. If stuck, explain your approach aloud. It clarifies thinking. Remember, interviews assess reasoning as much as final output. Practice helps reduce anxiety. Maintaining composure allows clearer logic, fewer mistakes, and better communication, all crucial for success in programming challenges. 19. What is the importance of writing clean code? Clean code is readable, maintainable, and easy to debug. It follows consistent naming conventions, uses comments wisely, and avoids redundancy. In programming challenges, writing clean code helps interviewers understand your logic quickly. It also reduces time wasted on debugging or rework. Even under time pressure, clarity and structure show professionalism and mastery. Clean, modular code demonstrates both efficiency and long-term software development discipline. 20. What is the best way to prepare for programming challenges? The best preparation involves consistent practice on platforms like LeetCode, HackerRank, or Codeforces. Focus on algorithms, data structures, and common interview patterns. Analyze each solution's time and space complexity. Review your mistakes to learn faster. Build problem-solving speed through timed sessions. Studying patterns and mastering fundamentals ensures confidence. Real success comes from understanding, not memorizing. Approach every challenge as an opportunity to think critically and improve continuously. Mastering programming challenges requires practice, patience, and problem-solving precision. By understanding these 20 core questions and answers, you'll be well prepared to tackle any technical interview confidently and successfully.